We're not going to get through everything in the notes, just the important stuff. Now, okay, ready? All right, we don't have a calculator for this lesson. I have a calculator. Change this to 0 to 2. What's the answer to this? No, it's not 4. No, it's not 3. No, it's not 16. No, it's not 8. Wait. Yo, team. Okay, Miss Calculator. Team, your calculator, when you plug this in, let's say we graph y equals x squared. It looks like x squared. And then you plug this in, and what does your calculator do? It accumulates, right? And you can see this if you graph y equals and you did second calc 7, right? Accumulate. And your calculator does the whole, accumulation, velocities times time. Your calculator knows that as accumulate. What do you know this symbol to be? Thank you for not forgetting everything. For you, you know this is anti-derived. So you all, my smartest, best class, forgot to take the antiderivative. The answer is 2.666667, which is just 8/3. Okay? Now, what did we just get this 8/3? Yes, it's the accumulation of x squared. Now, what does this look like in your calculator? It's the area, right? We just found areas. We found areas using antiderivatives. This was the only way mathematicians found areas before calculators came around. Cool? But they could answer questions, and you can answer questions like this, where I don't even give you an equation. You still don't have a calculator. But I give you the graph. Okay? So let's think like a calculator. Okay, let's think like a calculator, because you don't have a calculator, your first instinct, well, obviously not your first instinct, but most good students' first instincts are to take antiderivatives because you don't have a calculator. Well, that doesn't help me here. Okay? 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 So that should have been all y'all's first instincts, which it wasn't, but that should have been. But now, our second instinct should be to, let's think like a calculator. Let's think of this as accumulation from 0 to 3 of f. So now we can think, okay, if I accumulated f from 0 to 3, what am I going to get? Well, what we realize is that this accumulation is just like area. And what we realize is that we have triangles, objects in which there's geometric formulas to find areas. And you know that this is a base 2, height 2 triangle, and that the formula for the area of a triangle is 1/2 base times height. So you know that this accumulation would be 2. Please tell your neighbors, what do you think the accumulation is of this other triangle? It's a 1 by 1, base of 1, height 1. But what would I say it is? I actually would say this is -1/2. Why? Yeah, it's just like how, I gave you the graph of velocity back in the day, and we talked about how, like, this velocity is negative. I'm moving to the left. This area, this accumulation would be a negative number, right? And that would be how far I've went left. So areas underneath the x-axis are negative. 4/2 minus 1/2, 3/2. So we're thinking like a calculator. Our second instinct should be thinking like a calculator and then realizing, oh, I can use geometry. Yes, Arnold? No, don't do that. Don't do that. Waste of time. Waste of time. Waste of time. Because, like, look at this guy. This is a quarter of a circle with a radius of 2. Okay? And I can ask you to accumulate this function f of x from 0 to 3. And, like, you want to find the equation of that quarter circle radius 2 that's, like, flipped this way? No, you don't. You don't. So instead, we got to figure out a way to find this. And you will see, like, quarter circles, half circles in your lesson today. Now, what's really tricky is that this situation here is this quarter circle, and the quarter circle's area would be this portion. However, I want to find this area down here. There are some tricky things that you might see, which you can do using geometry, where it's like, oh, let's take this square and then subtract the quarter circle. So the square is 4. The quarter circle is 1/4 pi r squared. Remember, an area of a circle is pi r squared. That ends up being just pi. So the area in red is 4 minus pi. But then we also have this area here in red, which is a triangle. Okay? So don't turn it into an equation. Instead, just figure out the area using geometry. Okay? We're thinking like a calculator, and then we're using our geometric knowledge. Now, one thing we didn't really specify or really focus on is the fact that this A to B, that the order matters. Okay? We are accumulating starting at A, going to B from left to right. And if we're above the x-axis, usually we talked about this being a velocity, and then that would be like a positive displacement. If we're going from A to B below and our velocity is negative, we said, oh, that's a negative displacement. So that area is negative. Cool? But what we haven't done, but what you will see this lesson, is accumulating things from B to A. Now, you guys have an understanding of this already. For example, if I told you that my displacement from A to B was 5, okay? That means I ended up 5 to the right of where I started. Well, what do you think you would get if you go backwards from B to A? Yeah, you guys understand it's like we're doing the opposite of what we do like in like normal time. If we go back in time, if we accumulate from B to A, if you ended up 5 to the right, you got to go 5 to the left to get back to where you started. So B to A, and this is red, B to A, this is going right to left. All of a sudden, it's the opposite of what we think. All of a sudden, it's the opposite of what we think. So we just say it's the opposite of A to B. Here's another one. And here, let me show you. What some bright students did was type in, because they weren't sure how to get the answer, 0 to 2 of x squared, and they got that 2.66667 number. Watch. In your calculator, if you go 2 to 0, it gives you that negative number. Okay, so that just kind of confirms it. You would think, oh, it should be positive, but no, like it accumulates from 2 to 0. It's going back in time. It's telling you that. It actually does something different than what we do. Now, the next question is like, what if I went from like 2 to 2? What if I went from A to A? What do you guys think? Zero. There's no time. There's no time. Oh, if you travel 70 miles per hour from 2 to 2 or over 0 seconds, how far did you travel? 0. There's no time to accumulate anything. 2 to 2, 0. Okay? So, this is important. You're going to see this because we are going to deal with the accumulation function. The accumulation function, typically we have g of x, which is just like a different letter. It doesn't have to be G. It could be H. It could be like R. It could be Q. It doesn't have to be G. And we say usually that's equal to some accumulated area from a number to X. Now, we kind of introduced the variables and integrals last class, so it shouldn't freak us out. And then of some different thing, like F. Now, what you will see is that it's usually f of t dt, and this messes students up. They're like, why is this t's and this x? It's like, it can't be the same variable, or it's not accumulating an area under a function. So what I'm just kind of going to tell you is like, ignore this part, and you'll be fine. Okay? So here is our first accumulation function. G is equal to the accumulated area from, pay attention, this value could be different. Sometimes it's 0, sometimes it could be a negative, it could be 5, it could be whatever number I choose. So the accumulated area from 2 to x of f of t dt. Oh, I get worried about f of t dt. Don't worry, just pretend it's just f. And what do you have? Okay, I have the graph of f. All right? Cool? So if I say, what's g of 4? What's the answer? 4. Great. Because you're accumulating your area from 2 to, oh, I'm replacing x with 4. So x gets replaced with 4. This is read as, accumulation. Maybe your first instinct, because you don't have a calculator, is to take an antiderivative. Don't. That's not going to help you, unless you're some students who like to find equations of lines, and then you'll take the antiderivative of that. Don't. Instead, think more like a calculator. Let's accumulate f from 2 to 4. It's just the area. It's just a square of area. You can use your friend base times height or side length squared, and you get that answer 4. Now, what's g of 7? 2? No, but close. 3 is the correct answer. 3 is the correct answer because we are going to go from 2 to 7. Again, I don't care about the t's. Don't let that freak you out. It's just like accumulate f from 2 to 7. Well, I got the 4 from 2 to 4. Then from 4 to 5, this is a triangle. Base 1, height 2. This is 1. And then from 5 to 7, accumulating this, understanding that they're negative values. The accumulations are going to be negative. It's like kind of a displacement that's negative. We were told like the areas under our velocities were negative. This is a negative 2. 4 plus 1 is 5 minus 2 is 3. Okay, what's g of 2? Easy. We now know that there's no time to accumulate anything, so we just get 0. Now, smarty pants, what's g of 0? -3 is correct. Now, here's what I'm going to do. I like to maybe think about accumulating from right to left, but I'm still going to put this area here as being positive. It's like a rectangle and then a triangle on top. You kind of figured out that it's 3. I'm going to keep that as positive 3, even though it looks like I put a negative symbol there. I didn't. I'm going to keep that as positive 3. I'm going to show you why in a second. But when I say what is g of 0, I say g of 0 is -3 because I'm going from right to left. All right? Cool. Now, what I'm telling you is that this is exactly like something I've already given you in Unit 7. Okay? Just you had to do a little bit of work. Don't believe me? All right, we'll get there. Change this to just F. Okay? Ready? I'm going to get rid of this integral. I'm going to decide to be like a no calculator human being and not think of this as accumulation, but think of this as an antiderivative. And I'm going to give you a different expression for g without an integral because I'm going to take the antiderivative of f. The antiderivative of f, I'm going to say it's big F. Okay? We've done that back in Unit 6. And then what do I do with these things? We put this like line next to it, and then we plug it in. This is different. We're used to like 2 numbers, but now I have like an x and a pi over 6. Now remember, you plug in your final position minus your starting position, the c's will go away. So I get big F of x minus big F of pi over 6. Okay, cool. Okay, so up and down, next page, here I replace this with big F of t, with F of t, and then I said I got big F of x minus big F of pi over 6. Cool? I'm just repeating exactly what I did, but I'm showing less steps. Okay. Let's take the derivative of this with respect to x. Now, what do we say the derivative of big F of x is? Just regular F. You could say it's big F prime, but that's confusing. We just say it's regular F. Now, this is something that might be confusing to students because we think the derivative of big F of pi over 6 would be regular F of pi over 6. But big F of pi over 6 is just a number. A function with a number plugged in, I get a number. The derivative is just 0. Which means the derivative of the accumulation function is just F of x. Which kind of makes sense. You guys think of integrals as being antiderivative. If I take a derivative of an antiderivative, don't they just like go away? They're just like canceling each other out, and what's left is this? Yeah, kind of. It's actually with x's instead of t's. And look, it doesn't matter if it's pi over 6 or 12. You'll take the antiderivative, you'll plug in x, you'll plug in -12. You'll then take the derivative of that, and when you take the derivative of the accumulation function, it doesn't matter what this number is. This will just go away. It leaves you with that just with x's. Yes, Arnold? I'll show you in a second. Okay? You want to believe that you've already seen this stuff before, but you haven't seen the connection yet. Okay? You take the derivative of this. Oh, there's a pi here. Who cares? Goes away. It's just x sine x. Okay? Now here's the connection that I'm about to show you. Well, we typically said skip this, skip this, skip this, skip this, here. We said g of x is equal to this accumulation function, right? Right? Take the derivative of both sides. Next page. Take the derivative of both sides. The derivative of g, okay, I'll say that's g prime. What's the derivative of the right side? No. You take the antiderivative, and then you take the derivative. Okay. Which means g double prime equals f prime. Okay, cool. Get that. Which means, let's say you're asked for like a max min g. Well, you'd have to do your g prime sign analysis. Well, I just told you g prime equals f. You just kind of discovered that. Well, okay, f positive negative tells me g is going up or down. Maybe you're asked for when is g concave up or concave down? Well, we're going to have to look at g double prime. Well, that happens to equal f prime. See when that's positive or negative. That'll tell me when g prime is going up or going down. That's telling me when g is concave up, concave down. Not seeing the connection. I mean, this is familiar to me, but like, Mr. Semester, what the heck? How is this connected to Unit 7? Well, and why don't we change this back to 2, just so it was just like what we were dealing with. Well, let's go back to what we started with, this guy, okay? And it's like, okay, I'm given the graph of f until g is to the accumulated area of f. What's f? The same as g prime. You are given a graph of the derivative. Do you guys remember last unit 7, when I just gave you velocities graph, and I just gave you areas? It's the same thing, only you find the areas because you are given a derivative. Those areas are telling you how much are going up or going down. Yeah, but Mr. Messner, you had to give me like an initial condition, to find maxes and mins. You had to tell me x of 0 was like, 4. Well, I'll give you an easy point. G of 3, that's an easy point to find. What about G of 2? That's an easy point to find. You can find any point you want to start with, and then use areas you find to figure out how much G is increasing, how much G is decreasing. It's the exact same as this problem, but it's actually easier.
I don't know about that.
All right, well, let's see. Let's see if you guys are picking up what I'm putting down. Here we go. Part A of this question. This is a free response question. You ready? Part A. Find G of 3, find G prime of 3, find G double prime of 3. Tell your neighbors, what is it? That's the graph of G prime, that's the derivative. Right, we are just taking 3 and replacing x 2 to 3 of f. Okay, let's accumulate f from 2 to 3. It's just a rectangle of area. We can find that easily using our friend geometry. And I get 2. Oh, it's going to get harder. G prime of 3. Yikes. Well, I just learned that the derivative of this integral is just whatever we start with. It's just f. So find f of 3. Oh, f of 3 is like the y coordinate on f above 3. Oh, that's just 2 as well, but it's because that y coordinate 2. Maybe that's why I changed it to 4. So you don't get the same answer. What is g double prime of 3? 0, because f prime equals g double prime, so I just have to find f prime of 3. And f prime of 3 is 0. That's like back in unit 2. Remember those derivative rules problems where you had to look at like slopes of line segments? Yeah, like what's g double prime of 6? What's g double prime of 6? -1 is correct. F prime of 6 is the slope of this line segment. What's that slope? The slope of the line is the slope of the tangent down 2 over 2, -1. Cool. Now, what we realize, no, I'm not going to say that yet. I want to connect it to like what the second fundamental theorem of calculus actually is, but I'm not going to yet. This is just an extension of the FTC. Okay. All right. Next question. Free response question, part B. When is G decreasing? Don't say 4 to 7. Don't say 4 to 5 and 5 to 7. You are given the graph of f. This is not the graph of G. This is the graph of its derivative. This is G prime. Oh, G decreasing. I need to figure out when G is going down. How do I figure out when G is going down? When G prime, which happens to equal f, is negative. Oh my gosh, it's like, when am I moving to the left? When my velocity is negative. This is a velocity. When is it negative? From 5 to 7. Okay. 5 to 7. Five to 7. Now, if you go to the left, you're like, oh, I have negative numbers. I'll show you in a second. Like, that doesn't mean we're decreasing. Those are values. All right, part C. What is the absolute minimum value of G? All right, it's pretty simple. G as a min when G prime equals 0 or an endpoint. I already have my G prime sign analysis. Is 5 going to be the location of the min? No, but maybe we're going to do a little bit of work. We have options. We have either G of 0, G of 5, or G of 7. Let's find those values. We found them earlier. Find them again. maybe what's going to help us is writing down these areas right off the bat. All right, this was 3, this was 4, this was 1, this was -2, right? I split it into a rectangle, which is 2, and then a triangle base 2 height 1, which is 1. Added those two together to get 3. Now, 2 to 0 of f was -3, right? G of 5 is 2 to 5, that was 5. G of 7 was 2 to 7, so that's 4 plus 1 minus 2, so that was 3. Cool? What's the minimum value? -3, yeah, G of 0. Now, somebody was thinking like, well, if I go to the left, aren't I like decreasing because I'm accumulating like these negatives? But you know what? Let's just keep going, you know? And sometimes when you guys had the graph of V, what did you do? You found every single point here, 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 right? I could literally do that. All right, I found G of 0. What's G of 2? 2 to 2, 0. What's G of 3? We can add 2. What's G of 4? 4. 2 to 4, oh, add 2. Okay, G of 5. 5. I could go G of 6 if I wanted to. It'd be 5 minus a half. 4.5. G of 7, 4. What's happening? My G values are increasing until 5, and then they're decreasing. Oh, G prime is positive until 5, and then negative. When am I decreasing? From 5 to 4.5 to 4. When am I increasing? 0 to 2 to 4 to 5. But it's like easier to find because like you can find all the individual little like pieces of areas and kind of add those together. What was the extra layer of analysis? The areas, right? The displacement. What's the area from 0 to 5? 4, 5, 6, 7, 8. Remember, you guys would write this plus 8 underneath it. From 0, wait, did I write down 0? 0 is -3. G of 0, that was -3. From 0 to 5, I go from -3 to 5. Positive 8. From 5 to 7, I go from 5 to 4. Right. That's a 3. My bad. From 5 to 7, I go from 5 to 3. Boom. Minus 2. The same stuff. Looks different. Okay? It's actually easier to find more points because we can find all the areas because of these straight lines. It's not just like, oh, that's 2, that's -3, that's 4. Like part of this 4 is like, oh, I got a 3, then a 4, then I 1. Okay, but we're not done. Part D, see if you really understand things. Part D is, when is G concave up? We've not talked about concavity in a long time. And you might be thinking, no concavity, these are a bunch of straight lines. What is that? That's G prime. That's the derivative of G. Usually in unit 7, I just kind of did, you know, A is telling me about V. Well, I need to bring back G double prime telling me about G prime, which tells me about G. I want G to be concave up. Remember that? Which means G prime is going up, which means G double prime is positive. What do you have? G prime. When's G prime going up? 0 to 2 is correct. Or when are the slopes of G prime, or the slope of F positive 0 to 2. The same stuff, it just looks different. It's coming at you in a different way. Okay? Now, here's what actually the second fundamental theorem of calculus is. Go back. Now, I'm going to like say this, and then I'm going to be like, doesn't matter. It's confusing you. Don't worry about it. If G prime equals F, what's the antiderivative of F? Big F. G is big F. G prime is big F prime. No, it's what the second fundamental theorem of calculus is equating accumulations to antiderivatives, which is something you kind of already know, which is why I'm like, you know what? Just don't worry about it. Just don't worry about it. Don't let it confuse you. You guys know that you can accumulate. Your calculator does that. Or you can do that if it's straight lines and you find areas. Or you take the antiderivative. You kind of already know like that. That's the fundamental theorem of calculus. And that's kind of this as well. It's just the same stuff that we've done. Just looks different. What do we have until? Get your homework out. First page. Oh, I really don't like you here. But let's just go to the analysis question. Oh, this is. Oh, good thing. Well, no, listen, this is like exactly what I could give you. All right, that looks better. That'll be easier. Boom. What's the absolute max min values of G? Going straight to the question. Straight to the part D of the free response question. Go. G is the accumulation of F from -3 to X. Okay, so -3 is a starting point. That'll help us find actual value. This is the graph of F. Oh, you know G prime equals F. That's G prime. We want to find maxes and mins of G. You need a G prime sign analysis. Give me your sign analysis of G prime. We hit a 0 at what, -3, but we don't really change sign there. That is an important point, but not for G prime. We change signs at 2. This is telling me G is increasing, then decreasing. This is telling me my max must be at G of 2. Why? G prime is positive from -5 to 2. G prime is negative from 2 to 4. Please find G of 2 for me. Go ahead. What's G of 2? I wonder if I should redo the whole video. What's G of 2? 10? Anybody else get 10? Come on, find it. Here, guys, heads up. Here it is. Here's G. What's G of 2? -3 to 2. Accumulate F from -3 to 2. Right? Got it? Got it? That's it? That's it? That's it? Base of 1, 2, 3, 4, 5. Height of 1, 2, 3, 4. 4 divided by 2 is 2. 2 times 5 is 10. G of 2 is the accumulation from -3 to 2 of F, which is 10. Now, what's the min? Guess what, guys? I know it's gotta be at -5. Why do I know that? Because I look at this area here, and I know that, get our blue pen out. This is 10. 10. This is 2. That area of 12 is bigger than this area of -4. This is like what we did back in the velocity unit when we looked at the areas under velocity and think of them as displacement. This is displacement. This is an area under a derivative. I'm going to increase 12 and then decrease 4. Let's just double check that. Please compare G of -5 to G of 4. Find the correct value of G of -5. That's -3 to -5. That's right to left. And then G of 4, which is -3 to 4. Tell your neighbors what G of -5 is. I need everybody to get this. 3. 2. This is the base 2, height 2. If I'm doing G of -5, I'm going from -3 to -5. I'm going back in time. It makes sense that you're like going left. You get -2. What's G of 4? 10 minus 4 is 6. Let's just make sure this makes sense. -2, 6. What was the area under G prime from -5 to 2? Well, we had a +2 from -5 to -3. We had a +10 till 2, and then we have a -4 from 2 to 4. -2 plus 12, 10. -4, 6. You're given the graph of velocity. You find the areas. It's actually easy to find these points rather than here's my initial position, add your areas. It's the same thing. It just looks different. Next part, points of inflection. Then go. You're missing a good part, which is the harder problem. What are the points of inflection of G? Okay, that's when G double prime is going to change signs, right? Positive, negative, positive. Okay, so that's when G prime is going to change direction. That's when G is going to change concavity. Where does G prime, which is what's given to you, change direction? Or when do the slopes change? -3 and 0 is correct. Got it? You guys are start, okay? We're back to being the best class, okay? All right, but it gets harder. Go back to your notes. I might decide, you know what, G, it's not just the accumulated area. It's the accumulated area plus something else. Change that from an x squared to just an x. You find this? It's in the notes. So back in the notes. And then we'll go to the second page of your homework. Got it? Now, this is where it's very important to just like look at what you start with. Say, okay, G of 3. I'm replacing X with 3. So that means a 3 goes here and a 3 goes here. Pay attention. Oh, all of a sudden, I'm starting at 4 now. Pay attention to that. That's important. I'm not starting at 2 anymore. So I have 3 plus accumulate my area from 4 to 3. I'm going back in time. From 4 to 3, it's the opposite of 3 to 4. 3 to 4 is 2. This is negative 2, so this is 1. Okay, cool. Right? Now, G prime. Look at this right side and take its derivative. What's the derivative of that? No. 1 is the derivative of x. So this is why it's really important. This is next level stuff. G prime is actually 1 plus f. Because the derivative of x is 1 and the derivative of the integral is just f. So I need 1 plus f of 3. What's f of 3? 2. What's 1 plus 2? 3. Now what's G double prime? So 1's derivative is 0. So we're back to just like things making sense. And like G double prime is the same as f prime. The slope at 2 is 0. But watch this. This is what's really going to separate the good students from the great students. I am going to now ask you, when does G, this is part B or part D, have an absolute max? And what is the value? Okay? It might seem simple. Oh, Mr. Messner, we just did this. We looked at G prime. It's positive and negative. It changes sign at 5. So, x equals 5. Got to be. No, it's wrong. It's wrong. Why is that not the answer anymore? Pay attention. Don't wait until this hits 12:06. You have to get this. Why is the answer not 5? This is so important. This is literally the second page of your entire homework. Because the x I added. Because G prime is not f. G prime is 1 plus f. So you know what you have to do? Don't pack up. 2 things. Take f and add 1 to everything. Boom. Not at 5. That's 6. I actually don't like doing it that way. Here's what I like doing. I like to say, we always look at when derivatives equal 0, right? Well, G prime is 1 plus f. When does that equal 0? When f's negative 1. When does f equal negative 1? Is the intersection of y equals negative 1 in this line. It's at 6. This ramps up the level of difficulty of things. Now, if I ask you what is g of 6, it's almost like don't worry about all that stuff you did to find the location. Don't worry about any of that. Go back to what you originally did, which is you plug in 6 into here and 6 into here. 4 to 6 is that minus that, and that actually is going to be the max value. 6 plus 1 minus a half. 6.5 is the maximum value. That's intense. Don't worry, you have a 5-day-long weekend to forget all of that. And then you'll panic the Monday before you return to school on Tuesday, and that'll be fun. And then I'll probably have a new video up because I feel like I did a better job, honestly, than past years. Kept it to the point. Well, you were until you guys, none of you took the antiderivative. I forgot a major part, but that was 50 minutes.